Signs of the trigonometric functions. In previous module, module 5, we only work with acute angles, meaning that angles between 0 to 90 degrees, which are found in quadrant 1. In this module, we will learn how we can apply trigonometric functions to any angle. Just let's recall a little bit. We used xy and r plane to define xy plane to define the three primary trigonometric ratios along with r here. So if the point is xy, this x-axis we call the distance to be x here, this to be y, r is the hypotenuse or radius of a circle if you were to think about. Then using SOHCAHTOA, sine is opposite over hypotenuse, so y over r, cos theta is adjacent over hypotenuse, so x over r, and tan theta is opposite over adjacent, so y over r. Let's see example here. A point on the terminal side of the angle theta in standard position is given. Use a sketch to define the definition above to calculate the three primary trigonometric functions, sine theta, cos theta, and tan theta. So let's quickly sketch this. 1, 3 will be basically positive 1, positive 3. So somewhere here is 1, let's say, and this distance is 3. This point right here is 1, 3. This is a right angle. This is the theta, and r is unknown. So first thing we can do is find r. R square equals x square plus y square. In our case then, r square will be 1 square plus 3 square, so that's 9 plus 1, 10. So r is root 10. R is always positive. R is always greater than 0. So now that we have all three sides, we can write three trigonometric ratios as we are asked. So we can say then sine theta equals y opposite over hypotenuse, y over r. So in our case 3 over root 10. Similarly, cos theta is adjacent over hypotenuse, so x over r. In our case 1 over square root of 10. And lastly, tan theta we can say then tan theta here. Tan theta equals y over x. So in our case 3 over 1. So we can say 3. Let's see another one. If we have negative 4 and 2 as our point, so that will be basically x negative, y positive. So that will be in the second quadrant. So if we were to sketch, it will be looking like this. Let's say this is negative 4 and this is 2 here. So the angle theta always in standard position is this. This is the right angle. R is unknown. So we can again find r using r square equals x square plus y square. In our case, r square equals negative 4 square plus 2 square. So in our case then r square will be 16 plus 4, 20. So r equals square root of 20, or you can say it is 2 root 5. Now writing those trigonometric ratios again, we can claim that sine theta is y over r. So in our case 2 over 2 root 5, which is then 1 over root 5. Cos theta equals adjacent over hypotenuse, so negative 4 over 2 root 5. So that will end up being negative 2 over root 5. And lastly, tan theta equals opposite over adjacent. So in our case 2 divided by negative 4 or negative half. Okay. Similarly, if we have x to be negative 2, y to be negative 3, x and y both are negative. So it's somewhere in the third quadrant right here. If we were to sketch theta, it will be from here to here. X here is given to us to be negative 2, y here is negative 3, r is unknown. So we can quickly calculate r square to be negative 2 square plus negative 3 square. So in our case, r square equals 4 plus 9. So that's 13. R will be square root of 13. Once we have our r, we can write down sine theta equals y over r opposite over hypotenuse. So in our case, it will be negative 3 over square root of 13. Cos theta will be then adjacent over hypotenuse. So in our case, negative 2 over root 13. And lastly, tan theta is opposite over adjacent, negative 3 over negative 2, which then simplifies to 3 over 2. one more thing then, if we had x to be 3, y to be negative 1, and if you were to sketch that, x being 3 here, y being negative 1 somewhere here. So that's this. Again, angle in standard position always starts from positive x-axis, goes until here. So that's our theta here. R is unknown again. So if you were to find R, we can say R square equals 3 square plus negative 1 square. In our case, R square equals 10. R equals square root of 10. Once we have that, sine theta is y over r, opposite over edges, opposite over hypotenuse, so negative 1 over root 10. Cos theta is adjacent over hypotenuse, so in our case 3 over root 10. And lastly, tan theta will be then opposite over adjacent, so negative 1 over 3. Now, if we were to decide the quadrants, this is how the quadrants work. When x and y both are positive, we call it quadrant 1. X negative, y positive, quadrant 2. X negative, y negative, both negative, quadrant 3. And lastly, quadrant 4 is when x is positive, y is negative. So using this, if you were to fill this chart in quadrant 1, what are the signs, meaning that positive or negative for sine theta, cos theta, tan theta? So for the first example, when we have triangle in the first quadrant, sine, cos, tan, regardless of the value, they all are positive. So what we will put here is then sine, cos and tan, all of them are positive for the first quadrant. So if it's in the first quadrant, we have sine, cos and tan, all of them to be positive. So in our case, it's positive here, positive here and positive here. Now in the second quadrant, so that's my second example here, where x is negative, y positive, sine comes out to be positive, cos comes out to be negative, tan is also negative. Again, we don't care about the number, we are just looking at the sign. Sine theta is positive, cos negative, tan is also negative. So it will be positive, negative and negative. In the third quadrant then here, if you were to see, in the third quadrant, sine and cos both are negative and tan is positive. So it will be negative, negative and positive. And in the last quadrant, quadrant 4, if you notice, sine negative, cos positive, tan negative. So it's negative, positive, negative. So it is negative, positive and negative. So if you look here, from this we can have some general rule. Then in quadrant 1, all trigonometric ratios are positive. In second quadrant, sine theta is positive, meaning that its reciprocal, which is cosecant theta, will also be positive, while cosine and tangent both are negative. So their reciprocals will be negative as well. In quadrant 3, tan theta is positive, so sine and cosine are negative, and reciprocal of tan, which is cot theta, will be positive, and reciprocal of sine and cos, which is cosecant and secant thetas, will be also negative. Lastly, in quadrant 4, cos theta is positive, so meaning that reciprocal of that, which is secant theta, will be positive. All other 4 trigonometric ratios, sine, cosecant, cot and tan, will be negative. So if you were to summarize this in chart, this is how it looks like. We can use something called CAST rule, C-A-S-T, meaning that in fourth quadrant, cos positive, in first quadrant, all positive. So C stands for cos, A stands for all, S stands for sine, and T stands for tan. C-A-S-T. In fourth quadrant, all positive. In fourth quadrant, only cos positive. In first quadrant, all positive. In second quadrant, sine positive, and in third quadrant, tan positive. And whichever out of sine, cos, tan are positive, automatically their reciprocals are positive.